Good morning, this is your stat sensei, Mr. Spensey, and this is the reaction time scenario that we did a hypothesis test on. Now we're going to conduct a confidence interval. We're going to be asked to create a 93% confidence interval. So the scenario, Professor Andy McNeil measured the time in seconds required to catch a falling meter stick for 12 randomly selected students, dominant hand and non-dominant hand. Professor McNeil claims that the reaction time in the individual's dominant hand is less than the reaction time in their non-dominant. Professor McNeil has 220 students. The difference in reaction times are normally distributed. All right. So our job, create a 93% confidence interval for the mean of the differences in reaction time and explain the meaning of the confidence level. You do not need to verify the conditions. Why? Because we did that in the previous video. So if you want to see the conditions, watch the one on the hypothesis test. Now, I did have the data entered in the calculator. So there it is in stat edit. All right. And you can see the list of data in L1 and L2. I need to find the differences. To do that, blue 1 minus blue 2, and there that gives me my differences. All right, so my formula, x bar d plus or minus t star standard deviation of the sample divided by the square root of n. The d just represents we're working with differences of the mean. All right, unlike the hypothesis test, which is centered on the mean, the confidence interval is centered on x bar. So we're going to go ahead and calculate x bar. Stat calc 1 var stats, blue button 3. And there's x bar, negative 0.0131. So that's our x bar. We want a 97% interval, so we'll have a lower bound here and an upper bound there. It didn't ask us this, but I want you to know this. 1 minus 0.97, that gives me my alpha level. If I divide that by 2, I find the area in the tails. All right, and so I actually have the wrong area. This should not be 0.035. This should be 0.015, and this should also be, oh, no, I had it right. This is a 93% confidence interval. This is a 0.93. So yes, let's go back. Let's do that again. 1 minus 0.93 equals 0.07, which is what we have here. If we divide that by 2, we find out that we'd have 0.035 in each tail. So 0.035 here, and we also have 0.035 there. All right. So at this point, I usually just go ahead and run the test real quickly. Stat test, drop down to number 8. And here's why. Well, first off, data, we have data. We're going to press blue button 3 because that's where our difference is in. We need a confidence level of 0.97. And the reason I do that is not only do I get my interval, but I have my X bar D, my SD, and my N. Now I can get that from StatCalc 1 var stats. And I'm going to plug all that in, and the only thing I'm missing is my T star right there. All right, so I need to get T star. Well, to get T star, we're going to go second vars, inverse T, 1 minus 0.93, because that's my confidence level divided by 2. Make sure that's in parentheses. So 1 minus 0.93, close parentheses, divided by 2. Degrees of freedom is 12 minus 1, or you could just type in 11. And we end up getting a T star of 2.066. 2.0066. That's my T star. And when we previously ran it, we got an interval of this, and we need to make sure that we name it. And it's a one sample paired T interval for means, and this is my lower bound, and this is my upper bound. So we need to write our, define our parameter. Let mu d equal the true population mean of the differences in reaction time, dominant minus non-dominant. Always have to show the order you subtracted in. The conditions were previously satisfied. If you want to see them, you'll have to watch the hypothesis test video preceding this. And our conclusion, we are 97% confident the true population mean of the differences in reaction time, dominant minus non-dominant, lies within this interval. And there's our interval. All right. They did not ask this, but I'm bringing this in for free. So for free, 0 is not contained in the interval. And because it's not contained in the interval, there appears to be a difference with dominant hand being faster. All right. And the reason I know that dominant hand is faster is because all the values were negative. All right. If they'd been positive, non-dominant would have been faster. All right. The last thing, they don't always ask for this, but if they ask you to explain the meaning of the confidence level, you always have to give, always give this. You always have to give a conclusion. The meaning, they don't always ask for. It's never wrong to give it, but they don't always ask for. Is in repeated sampling, we expect this method to capture the true population mean of the differences in reaction time, dominant minus non-dominant, 97% of the time. In other words, our method is so good that if we did it over and over again, 97% of the time we'd get it right. But that also means 3% of the time we would not capture the mean, capture the true population mean. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.